All right, so we're going to start section 3.2, and some of this is going to be a review. In 3.2, we're going to look to see if we can create, interpret, and use equations, graphs, or tables of linear functions. And we're going to translate from one representation to another. So we are on page 14, right after those constructed response questions. Let's first start with this here that says functions can be written as equations, tables, mappings, ordered pairs, and graphs. Each can represent the function in a different way depending on its intended use. So let's first look at tables and ordered pairs. Function tables that are tables will include independent variables, which like I said is typically x, and dependent variables, which is typically y. The values in the table are determined in choosing values for independent variables and substituting them into the function to figure out what the dependent variable is, and then those answers are given as ordered pairs x, comma, y. Example 1. The equation that represents the relationship between the number of hours a student studies x for a test and the student's test score is y equals 5x plus 15. It says create a table and set of ordered pairs that represents the situation. So we have here a function. This function is y equals 5x plus 15. This function is representing what a student's test score will be depending on how many hours the student studies for the test. It tells us here that the hours that a student studies for a test is x. So it tells us that x represents the number of hours studying versus y represents the test score. This is why x is your independent variable and y is your dependent variable. Because of this idea that your test score depends on how many hours you study. Because of that, your equation starts with what y is equal to. If you study for 1 hour, you would replace 1 in for x, multiply 5 times 1, and then plus 5, and then that will be your overall test score. It's telling us to choose any values for x. So if we were going to create our own table, when I'm thinking about numbers I want to choose for x, and x represents the number of hours studying, the smallest number that makes sense for this problem would be what? What's the smallest number of hours you can study for a test? It's even smaller.
Not a 3 hour.
A second, or even less than that? Even less than that. You don't have to study at all, right? So for this problem, the smallest number of hours we can study, I guess we could put 0. Now that's not recommended, right, to not study at all, but the smallest number of hours we could study is 0 hours. Now it's asking us to just create any values we want for x. Now I don't know what type of test this is. I mean, if it's like a test to get your doctorate or just a test for algebra, like you might spend a different amount of time studying. But let's just go by, let's say, 5 hours. So like 5 hours, then 10 hours, 15 hours, and 20 hours. The function says that in order to tell what your score is for this test, you take the number in for x, replace it in for here, and then solve for y. The equation is y equals 5x plus 5. So we're going to be putting in here y equals 5 times 0 and then plus 5. And that's going to tell us our score. Well, if we study for 0 hours, 5 times 0 is 0 and 0 plus 5 is 5, our score is going to be a 5. I don't know if this is actual percents or if this is just scored differently, but the score would be 5 for that one. Then the next one, I'm going to do the same type of thing, but instead of replacing in 0 for x, now I'm replacing in 5 for x. So it's going to be 5 times 5 plus 5. Well, 5 times 5 is 25. 25 plus 5 is 30. So your score would be 30 if you study for 5 hours. And moving down the line, y equals 5 times 10 plus 5. 5 times 10 is 50. 50 plus 5 is 55. Hopefully these aren't percents because this is not a very high score for studying for 10 hours. Moving down the line again, I would multiply 5 times 15 hours and then add 5. 5 times 15 is 75. 75 plus 5 is 80. And then last one, I'm going to multiply 5 times 20 and and then add 5. And 5 times 20 is 100. 100 plus 5 is 105. So when you have a function and you have an equation, your dependent variable, which is always y, depends on what x is. The test score that you get on this particular test depends on how many hours you study. Look at your score when you study 0 hours. You get a 5. However, if you study for 20 hours, you get 105. And if this is in actual percents, if you study for 0 hours, you're definitely not going to pass. If you study for 20 hours, which is a lot, you will get over 100%. That's 105. So that's the way tables work. Mapping diagrams is something that we already have learned, so this should be pretty quick. A mapping diagram is a diagram that visually shows the relationship between the domain and range. And the domain is listed in the first oval and the range is in the second oval. To create mapping diagrams, your domain is always x and your range is always y. We already know to do this, or you might not know how to do it, but for your domain, you're just listing the numbers here in the oval. 1, 2, 3, 4. And you list the range in this oval, 10, 20, 30. And we don't need the other 30 because it already was written once. You don't need it twice. And then you just draw arrows from the numbers that associate with the domain to the range. So 1 goes to 10, 2 goes to 20, 3 goes to 30, and 4 goes to 30. And that is your mapping diagram.